Okay, girls, so as I was saying with the previous example, in this pattern of numbers, we can see that each term needs to be defined depending on the previous one. So I need to know that this term is 7, and then I can add 3 to know that the next one is 13. But if I want to know which is the term that happens after 1,000 times of doing this, I don't know, like I will have to do it until I get to that point. So let's see another example and then we will generalize this idea. So consider the following set of shapes. So we have three matchsticks, I think they're called, that are forming a triangle, okay? So this says, construct a table to show the relationship between the number of shapes in each figure and the number of matchsticks used to construct it. So let's start there. So let's look at this. It's talking about number of shapes. Which shape do we have there? We have a triangle. Can I highlight this? Number of shapes and the number of matchsticks. Okay, good. So I'm going to do that first. So to do that, we're going to create a table. You're going to do exactly the same. Your table is going to have number of triangles. I hope yours is much more straight than mine. A number of sticks. I'm going to call it sticks. Okay. So if we go up and we look at this, the first one, how many triangles do I have? 1, then I have 2, then I have 3. Okay. So let's do this one. I have 1, then I have 2, then I have 3. Okay. How many sticks do I have? 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So in the first one I had 3. In the second one I had 6. And in the third one I had 9. Okay. So I've completed part A. Then it says, write a rule in words that describe the pattern relating the number of shapes in each figure and the number of matchsticks used to construct it. Okay, here they're saying to use words. Because you already have done algebra, we're going to start using algebra. So, very important. First step, you need to define your variables. So we're going to say, let x be the number of triangles. Okay, I'm going to call that is going to be my x. So basically, if I extend, I'm calling this one x. Okay, and I'm going to define another variable that I'm going to call in this case y. Let y be the number of sticks. And we can see what is the relationship. So underneath here, this table in this one is going to be called y. Perfect. So what is happening when I have one triangle? What is happening here? We can see that I'm timesing by 3. Do we see that it's happening every time? I times this one by 3. Then I times this one by 3. So you see, this is different from the example that we had before, because in this case, I don't need the previous. I don't need to know this 6 to go into this 9. I need to know is the number of triangles. So if I want to extend this, and I want to know if I had 20 triangles, how many sticks will I need? 60, sorry. 60. And if I had 1,000 triangles, how many sticks would I need? 3,000 triangles. How do we know that? Because we have to multiply this one by 3. So let's try to write this rule. What is happening here? So if we define our variables as x and y, x being the number of triangles and y being the number of sticks, I can say that y, oops, sorry girls, y equals 3x. Okay, so depending, and as you can see, if I sub in, for example, 20 triangles, I get that y is equals to 60. So that's our rule. So our rule helps us to find any term that we need, regardless of the previous one. So we don't have to do the iteration 1,000 times to get to the number that we're looking for. Then it says, use your rule to work out the number of match keys required to construct a figure made up of 20 such shapes. So this one is the one that we have. So with 20 shapes, then I will have 60. So if we only have to sub in, so y equals 3 times 20, y equals 60. So our answer is, we have to state it in a complete sentence. So this is, we need 60 sticks. And that's our answer. Good. I'm going to stop here, and then I'm going to do the next example in the next video.